Ready-made maths YouTube mathematics training. Teacher and teaching assistant training. This is a bonus video, as promised, on short division, looking at the written method of short division. What we're going to be doing in this video is looking at a real understanding of the colloquial bus stop method. We're going to look at how it can be visualized, how it can be made, how it can be created, and how it can actually be explained so that it makes sense. Looking at an example, a very brief one, of short division using the bus stop method, what do we say when we see this calculation? Do we have any background understanding to the numbers that are represented in 72 divided by 4? What language do we actually use? What do we say when we're looking at the 72 divided by the 4? Is that the right language to use? We're going to explore that a lot in this particular video. What language should we use when we're doing this calculation in order to give it a real understanding? And far more importantly, that gives us all of this is, first of all, is there an image or a manipulative that we can use that will really help with understanding short division? That's what we're going to be looking at over the course of this video. We're going to be taking calculations such as these. How can we show and explain 56 divided by 4, 78 divided by 6, 91 divided by 7, and so on? Can we show them using apparatus rather than just going straight for a method? So what we're going to be seeing in this video is each of the calculations that you can see there represented with apparatus and therefore explained. We're going to then develop that into 3-digit numbers towards the end of the video, where again you'll see the same resources used to build up that bigger picture. 136 divided by 4, 265 divided by 5, and 372 divided by 6. We're even going to move towards the end of the video for the final calculation into a 4-digit, 1336 divided by 4. Can we actually make that? What does it look like? Can we rearrange apparatus? Can we manipulate? Can we play? So that at the end of the session, we're not just doing a short division method, we've actually got a full, concrete, real understanding of what that method really means. Good morning and welcome to a special edition of the Ready-Made YouTube Mathematics channel. In all the previous videos, we've been linking together mental mathematics, early years, place value, and then mental multiplication. This is a special one-off video looking at something which I did mention earlier on as something that causes a lot of issues within Key Stage 2. And that's the colloquial bus stop method of division, or the standard method of short division. In this particular video, what I'd like to do is explore why that method causes so many problems. And a lot of it goes down to the fact there's no picture behind the method. Children are getting taught to do something, but they're not thinking about what it actually means. They're just kind of following a procedure that the class teacher has taught them to do. So what I want to do in this particular session is explore the picture behind short division, so that you can see why it works, and then if you're teaching this to a group of children in year 3 or year 4, they can really visualize and understand it. Now, there are many more things we could cover in division, and this is just one small snapshot of the whole process of teaching division. Obviously, in Key Stage 1, we're starting off with grouping and with sharing and building up images around those. We're also then in lower Key Stage 2 linking multiplication facts to division facts and having pictures and models and images of times tables, the arrays and so on, and the repeated addition and groups, all of which go together to build up a picture of what division is. I'm going to assume that that's been put into place, and we're now in the stage where we're going to introduce for the first time short division or the bus stop method to the children. We're going to see what it looks like, we're going to picture it, we're going to work through a few examples, and hopefully at the end of the session you'll be able to actually think, that's why it actually works. Shortly we're going to look at these 3 calculations and many more and build up the picture behind the method. But I think just to begin with, just very briefly, let's just look at 3 calculations that you'll potentially give to children in year 2 and then maybe in year 3. And let's look at the different ways that those 3 calculations could be answered. We're going to do this very quickly. We're going to use the abacus and we're going to use little pictures of cupcakes, and we're just going to examine the 2 images that children need to be brought up with when they're being taught division. It's not one way of teaching, they should be brought up with 2 different procedures through which they develop their understanding of division in Key Stage 1. Now, when children are introduced to division for the first time in Key Stage 1, the principle that they're usually introduced to is division by sharing. Simple example, we have 12 cakes. Those 12 cakes are shared between 2 children. How many cakes each? We just count them out. 1, 2, 3, 4. We're sharing as we're doing it. 5, 6, 7, 8, 9, 10, 11, 12. You can see straight away that both of the children have been given 6 cakes each. Very, very simple division by sharing. What we could also do, similarly, is division by grouping. This is taking the same 12 cakes but putting them in bags of 2. Cakes are put into bags of 2. How many bags are there altogether? For this one, we need to count in 2s, not 1s. How many 2s in 12? Division by grouping. Let's have a look. We're going to go to the bottom of the abacus for that. 2, 4, 6, 8, 10, 12. How many 2s are there in 12? There are 6 2s in 12. So in the first instance, division by sharing, we're looking at how many there are in each group, because we're saying 12 shared between 2 gives us 6 each. In the second example, we're looking at how many groups there are. How many 2s are there in 12? 1, 2, 3, 4, 5, 6. There are 6 2s in 12. The answer is still 6. We're just looking at it a different way. Now, every division calculation can be done that way. Let's just take those other examples really quickly from the board. 15 divided by 5. 15 shared between 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Straight away, we've shared 15 between 5 people. How many have they got each? Each person has got 3. Division by sharing. At the bottom of the abacus, we'll look at division by grouping. How many 5s in 15? 5, 10, 15. There are 3 5s in 15. As you can now see, it is the same array, just inverted. We're just reading it in a different way. We can read it as 15 shared between 5, so they get 3 each. Or how many 5s in 15? There are 3 5s in 15. In year 2, children need to get used to that idea of every division in the world can be done 2 ways. We can basically try it as a division by share or division by group using small amounts. Now, obviously, as we move into Key Stage 2, you'll start to realise that some divisions are done far better by sharing, some are far better by grouping. Sharing will eventually lead into fractions, and grouping will eventually lead into kind of the normal horizontal method of mental division that children do when they're looking at the inverse of their multiplication facts. As a simple example, 24 divided by 3. By year 3, the children aren't really thinking 24 shared between 3, they're thinking how many 3s in 24 and linking that back to a times tables fact, 8. But they could quite easily share 24 between 3, that will become a third of 24, the fraction idea, and they'll find that 24 shared between 3 will give the children 8 each. So 24 shared between 3 would in effect look like that. 24 shared between 3 would look like that. How many 3s in 24? 3, 6, 9, 12, 15, 18, 21, 24 would look like that. Yep. What I've done just very, very quickly is also show those 2 methods, again as I would probably do early in year 3, so that children can see 24 divided by 3 physically both ways. So we look down at the table. At the top here, we can see 24 cakes shared between 3. So I basically shared the cakes out, and you can see that each person has got 8 cakes each. So that's the sharing method, or the fractions method. What's a third of 24? 8. And what's 24 shared between 3? 8 each. Looking at the other set of images, this is the kind of bags of cakes. We have 24 cakes, they're put into bags of 3. How many 3s in 24? And we can see 5, 6, 7, 8. There are 8 3s in 24. We've got to establish both those and do them as often as possible so that children get used to that idea that when I see or hear a division calculation, I've got 2 different options. And I've got to decide which one is preferable depending on the actual calculation they're being asked to answer. So now let's get to the main part of today's session. The short division explained, or as it's colloquially known, the bus stop method. Simply because the actual image looks a little bit like a bus shelter. So,
56 divided by 4. I want to have a look at that calculation now. I'm going to write that one on. I'm also going to write 78 divided by 6. I'm going to write them in that conventional format of the kind of traditional bus stop method. And what we're going to do now is we're going to pause the video, and it'd be lovely if you had somebody to talk to at this point. If not, almost talk it through to yourself. But as you're following each of those methods, what are you saying to yourself? What is the language mathematically that's going through your head when you're working out 56 divided by 4 and 78 divided by 6? So in turn, go through both of those and talk to yourself, or preferably talk to somebody else and explain what you're saying as you're doing those methods. Now, I imagine the majority of people looking at this would say something similar. Something to the extent of, how many 4s are there in 5? How many 4s in 5? 1. There's 1 4. There's a remainder of 1, so I put that 1 next to the 6. That now gives me 16. How many 4s in 16? 4. And the answer is 14. I'm certainly not arguing with the answer. The answer is 14, but I want to think about the method shortly. Let's look at the second one. What are we saying now? How many 6s in 7? Again, there's 1 6 in 7 and remainder 1. How many 6s in 18? 3. And if that was taken to an example where it wasn't a remainder of 1, let's just say if we had, let's just go for 91 divided by 7, something like that one. If we had 91 divided by 7, what we're saying to ourselves there, just draw a quick one underneath. Put my 91. How many 7s in 9? 1. Remainder 2. How many 7s in 21? 3. Now, obviously that gets the right answer. But what does it really mean? Let's have a look at this example again. Imagine you just spent, let's say, the previous 6, 7, 8 weeks taking the children through place value, where you're really showing them hundreds, tens and ones and getting that place value secure. You then taught them addition and partitioning, where you talk about the 5 as being a 50, and subtraction in the same way. We talk about the 7 as being a 70 and the 9 as being a 90. And then we do exactly the same with multiplication, where we're doing, let's just say 56 times 4, 4 times 50 and 4 times 6. We've used apparatus, we've used base 10, we've used place value counters, we've made the calculations for addition, subtraction and multiplication. Yet suddenly, we're back onto this one and we're saying to ourselves, how many 4s in 5? Pause for a minute, what's wrong with that? Hopefully, when we start to look at it and we start to think of what we're actually saying, how many 4s in 5? Well, that isn't actually 5, it's 50. It's got a value of 50. It's got a value of 5 tens or 50. But if we were to say how many 4s in 50, well, the answer is 12. Remainder 2. 12 4s are 48 and 2 is 50. We can't write 12 up there. So really, though, we shouldn't really be saying how many 4s in 5, because even if we say how many 4s in 5 tens, there's still 12 4s in 5 tens. So what we're saying to the children doesn't make sense in a place value, in place value. Again, if we're to look at this same example here, how many 6s in 7? Well, that's actually 70. If I said to a child, 70 divided by 6, what's the answer? Well, written like that, 70 divided by 6, the answer is, how many 6s in 70? 11 remainder 4. So that's the actual answer without any fractions, but that's the actual remainder answer to 70 divided by 6. Yet we're suddenly saying, how many 6s in 7? 1 remainder 1. It doesn't seem to make any sense. And for years and years, we've taught this in the UK. We've taught children a method that's got no understanding behind it. 70 divided by 6 is 11 remainder 4. I'm not writing that up there. Instead, I'm saying how many 6s in 7, how many 7s in 9. We've got to have a better way of explaining it. And luckily, it can be done. All of these methods can be taught with understanding. I'm just going to remove them for a minute. I'm going to just write this one down here. For me, this is the one that really brings out that idea of the mathematical language. Again, 136 divided by 4, done the kind of old-fashioned way. How many 4s in 1? 1? 1. How many 4s in 1? None. So I now I either cross that out and put my 1 over here, which some schools teach, or other schools join the 1 and the 3 together to make 13. Let's just imagine I do the crossing out version. How many 4s in 13? 3 remainder 1. And how many 4s in 16? 4. Again, the answer is correct. The answer is 34. But let me take you back. How many 4s in 1? That is definitely not 1. It's worth 100. How many 4s in 100? 25. I'm certainly not writing 25 up there. How many 4s in 30? 7 remainder 2. I've got 3 written above the 3 at the moment. Why? And then how many 4s in 6? When we start to think of the language behind it, we're suddenly thinking, are we using the right language? How many 4s in? Or is there a better way to do it? Well, that's what we're going to look at now. We're actually going to look at what that really means, what this really means, what this really means. We're going to make the calculations on the table and try and explore them in the way that you would do in a mastery curriculum such as in the Far East. Let's begin then by looking at 56, and I've made that with 10s and 1s with base 10. If we were doing anything on partitioning in key stage 1 or lower key stage 2, we would get 5 10s and 6 1s. If we were to do subtraction, we will take some 10s and 1s from that amount. If we were doing multiplication, we would get that 56 and multiply it. What we are doing is division, and I think it's really important we start in the same way as we would for any of the other operations. 56 divided by 4. The problem we have is that language. How many 4s in 56? It doesn't work. It can be made to work if we look at it in a certain way, but it's actually much easier to think of the other principle of division. We're currently thinking of division as grouping. How many times does one number go into another? Let's go back to that original principle of division. Division by sharing. 56 shared between 4. Let's look back at the table now. Okay, we've got 56. We're going to share that between 4. I'll write the calculation at the top so we can see it. So 56 divided by 4. That's the calculation. But let's now think of it from a sharing principle rather than from a grouping principle. Let's start with the 10s. Again, with division, unlike the others, we start with the most significant digits. So we start with the 10s. Right, let's think now. I've got 5 10s. I've got 5 10s here. I'm in 10s and I want to share those 5 10s. Those 5 10s between 4 people. Let's see if we can do that. 1, 2, 3, 4. Yep, we've managed that. We've shared 5 10s between 4 people, but there's 1 10 left. Now, this cannot be physically shared at the moment. We can see that there's other numbers within it, but currently it's a 10. We've shared 4 of the 10s. That 5th 10 cannot possibly be shared between 4. So the only thing I can do to make this work is now to exchange my 10 for 10 1s. So what we're going to do is exchange that 10 for 10 1s. I'm going to bring those 1s over here and put them with the 6. Again, you can see at the moment I've kept it all in 5 style just so you can see them straight away. We can now see 16. We've got 16 1s. Can those 1s be shared between 4? 16 shared between 4. I'm going to use my knowledge of tables facts, and I know that I could do this individually in 1s, but I'm just going to put the 4s over there. And that leaves me with a final 4, which I'm going to put over here. And that, at a very simple level, is exactly how the bus stop method could be taught so that children understand what they're doing. Let's not start on the board. Let's start with apparatus and let's just share it. It then just becomes natural. The children will follow that sharing principle and they'll be able to see what they're doing and be able to explain it. Let's try the second one, which was 78 divided by 6. I'll make that really quickly. 10, 20, 30, 40, 50. That's my 50. And we'll get 2 10s from over here. That's 70. And I'm going to get 8. 1, 2, 3, 4, 5, 6, 7, 8. I'll just remove those for the time being over here. Let's have a look. 78 divided by 6. How many 6s is 78? Not anymore. 78 shared between 6. I'm going to remove that. I'm going to write the calculation here. 78 divided by 6. I've got my 10s and I've got my 1s. Okay. 78 shared between 6. Where do I start? I start with the 10s. I've got 7 10s and I need to share those 7 10s between 6 people. That's all I need to do. 7 10s and share them. 1, 2, 3, 4, 5, 6. Again, as before, I'm just left with 1 10. That 10 cannot physically be shared. So what I'm going to do is, as before, I'm going to exchange that 10 for 10 1s. So I'm going to put that 10 over here, exchange my 10 for 10 1s. Again, I'll put them in 5 styles so it's easy to see. And what I should now have, and you can see that we've got the number we started off with. What we've now got is 60 and 18. 6 10s and 18 1s. The 6 10s have been shared, the final 10 has been exchanged for 10 1s. I've got 18 1s, share them between 6. I'll just use my tables facts there. I'm going to put 3 over there. I'm going to put 3 over there. Another 3 here. another 3 here, another 3 here, and another 3 here. What we've ended up with is basically 78 divided by 6 gives each of the people 13. There's been no how many times does something go into, it's all been done through very simple sharing. What I'd like to do now is ask you to look at the two calculations that you can see. 72 divided by 4 and 96 divided by 4. These are slightly more complicated than the previous two. I want you to think about the first one, the 72. What's going to happen when you share those tens as they are in tens between 4 people? What's going to happen with the 96 when you share those? So think carefully, it's slightly different with each of them. What I'd like you to do is possibly at home using something to represent tens and ones if you could, or even possibly using a drawing, just drawing little sticks to represent the tens and dots to represent the ones. Can you show me the picture of what's going to happen with both of those calculations, with the 72 divided by the 4 and the 96 divided by 4? Hopefully, what you came up with is something like this. We initially had our 7 tens. There's 3 tens here and there's 4 tens here. We shared the tens, and so each person got a 10. And that actually left us with 3 tens. Now, unfortunately, because we're sharing between 4, even with 3 tens, that's not going to help. So each of those 3 tens need exchanging into ones. So that's what we did. What we've ended up with now are 32 ones. Those 32 ones can then be shared between 4. And just very, very quickly, again, each time for these, I'm just going to use my tables fact. They could be individually shared into ones, or we can just use our tables knowledge. Just going to put those down there. I'm going to put 8 in each one, and that does leave me with 2, 4, 6, 8. Again, for children that don't know the tables facts, they can just share those 32 between the 4 until they end up with 8 each. So we can see there that 72 divided by 4 is 18, following the principle of sharing. If we move to the other example, the 96 divided by 4, this was different because actually this time, because we had 9 tens, each person got 2 tens, 2 tens each, 20, 40, 60, 80. The remaining 10 couldn't be shared, so that was exchanged for the 10 ones. We've now got 16 ones, and as before, 16 shared between 4 gives 4. So these are a bit fiddly. 8, 12, and then those final ones go over there. So again, we end up with 96 divided by 4 equaling 24. If this principle is taught from the word go, and children get used to always seeing it as a share, make it, share it, talk it through. Exchange, talk it through. Physically share, use your tables, facts. There's no reason why the vast majority of children can't really understand what division is all about. That comes well before they transfer that over to pencil and paper, because if they can explain it visually, then I think what we're going to see in a second is the method will start to make sense. We'll just take a look at the first 2 examples that we did, the 2 that we saw over here. Now, let's imagine we've just spent a couple of lessons going through all of that on the table, visually making it, and then developing that into pictorial versions as well. Then we just write this up. We ask the children to explain what they did. What did you do on the table with 56? Well, what we did was we got the 5 tens. We got the 5 tens. We didn't say how many 4s in 5. We got 5 tens and shared them between 4 people. That gave us 1 10 each. It's exactly what we did on the table. We had 1 10 left over. Now that 10 couldn't be shared as a 10 between 4, so we had to exchange it for ones. That gave us 16 ones. They were shared between 4. And we got 4 each. I think you can suddenly see now how this method completely makes sense. We're talking about it in a different way. We then moved on to 78 divided by 6. Well, what did we do? We got 7 tens. We shared those 7 tens between 6. 1, 2, 3, 4, 5, 6. They got 1 10 each, and there was 1 10 left over. That 10, as we saw, that can definitely, as it currently stands, not be shared between 6. But as soon as we exchange it to ones, we've got another 10 ones over there. We've now got 18 ones, which can definitely be shared between 6. That gave us 3 each. I think again, suddenly with the right explanation, we can see what this really, really means. And the short division method can now be explained very effectively with the children backing it up by something that they've just done practically in the classroom. So let's take a look at the third calculation that we did on the table earlier on. 72 divided by 4. What did we actually do with the 10s and the 1s? Well, as before, we started off with 7 tens and 2 ones. What did we do? We actually didn't say how many 4s were in 7. What we did was we said, we have got 7 10s. Let's share those 7 10s between 4 people. So each of the 4 people got one of the 10s. This time, unlike before when we had 1 10, this time we had 3 10s left over. Those 3 10s cannot be shared as 10s into 10s between 4 people, so we had to exchange all of those 10s into 1s. So this time we had 1 10 each, 3 10s left over. They all became 1s, and we actually then had 32 1s. We shared those between 4 people, and we ended up with 8 each. So even when the calculation gets a little bit more complicated, it can still be explained. What we also looked at was the calculation 96 divided by 4. With that one, what I'd like to look at is just the idea of drawing it out as well. Because if we're going from the concrete to the pictorial before moving to the abstract, this stage needs to come in between. So actually it's a really nice idea for yourselves to practice it, but also to get children to draw the calculation as well. So it links in between the work we've done on the table with the actual written method. So let's look at this one. We've got 9 10s that I've drawn out here and 6 1s. I need to share them between 4. So again, unlike all the other operations with division, we start with the most significant digit. We've got 9 10s, we need to share those between 4 people. And again, we can cross them out as we go if we want. 1, 2, 3, 4. Let's share out our first 4 10s. 5, 6, 7, 8. And straight away we can see 1 10s left over, exactly like we had on the table. That 1 10 cannot be shared in 10s between 4 people, so it needs exchanging into 1s. So I'm now going to exchange that, get my black pen, I'm going to exchange that for 1s, so we have an extra 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As we can see, 10, 15, 16 1s. Very quickly, we'll share those between 4. I'll just imagine I know how to do this one, so I'm going to take those 4 and put them in there. 1, 2, 3, 4, those 4, and put them in there. 3, 4, those 4, put them in there. 1, 2, 3, 4, and then we've got 1, 2, 3, 4 left. So 96 divided by 4 equals 24. As soon as we write that as a method, there's the 96, there's the 4. What did we do? We took our 9 10s, we shared them between 4. You can see there, 2, 4, 6, 8. They are the 2 10s each that we got. We had this 1 10 here that was left over, which we exchanged for 10 1s. That left us with 5, 10, 15, 16 1s. We shared them between the 4, and we ended up, there's the 16 1s, we shared between the 4, and we ended up with 4 each. So again, it can be proved with apparatus, it can be proved as a drawing, and we can now explain it. What we're going to do now is we're going to go back to the table, we're going to look at a slightly higher level calculation, some 3-digit calculations, and let's operate on those in exactly the same way.
What you can now see is an example from the sense of number visual calculation policy. I know I've mentioned this in many of my videos. It's a fantastic policy to get hold of. Have a look at senseofnumber.co.uk, and there are examples of written, concrete, mental methods for every single type of calculation, all the way through the primary school years. This is an example of 72 divided by 4, and it should look very similar to the example that we've just seen back in the ready-made maths classroom. There's an alternative image here on grouping. What we looked at was this. We started off with 7 10s and 2 1s. We then shared our 10s, the 4 of them. There were 3 10s remaining. We exchanged each of those 3 10s, as you can see up here, for 30 1s. We've now got 32 1s, and they were shared equally between the 4. And so each of them had 18. Again, if you've got a copy of this, it's really nice to have it on a working wall that children can work through. It's also fantastic to have an image such as this printed out as a handout for children to write on, and they can physically do the same thing back in class as well. And so really, this is what mastery is. Just looking at the calculation 136 divided by 4, which we're going to be seeing shortly, by the end of the session, what we should be able to do, first of all, is tell you what that calculation means. Potentially tell you a story about it. We're not really looking at the stories today, but there's a little bonus video that will develop a story around bus stop division. Can I remember the facts I need? So I bring in the multiplication. Can I explain each of these digits and what they're actually worth and link them back to the division? Most importantly, can I actually explain what I'm doing when I'm following this calculation? Can I use what each digit is worth? Can I use a manipulative and can I use all of that to help me explain what this calculation really means? Then I can reason how I know the answer is accurate. So what can I do at the end in order to prove that I know the answer is the correct one? And something that we could use in a follow-up video, can I also find the answer using a different strategy? So in order to master short division, what we're going to be doing today is pretty much the first, third, fourth, fifth, sixth, and seventh of those. We'll then, in a bonus video, look at the story, and hopefully in some future training, we'll look at alternative strategies for division.
So let's have a quick look now at the calculation 136 divided by 4. If we're looking at the real meaning behind it, rather than just how many 4s in 1, which obviously you can't do, we can actually see that within the 100 there are 25 4s. Let's have a quick look at how that could look if we're doing it as a sharing activity. So let's just pause the video for a minute and just think to yourself what's going to happen when we say 100 shared between 4 as we continue with that calculation. So hopefully the first thing we've said is, well, it's 100 and we need to try and share that 100 between 4. We can't do that in hundreds because it's 100. What do we need to do? Exchange that for 10 tens. So we'll remove that 100, exchange that for 10 tens, and now, again, set out in 5 style, we've got 13 tens. 13 tens, 130. We've still got 130 as we had before, but now it's all in tens. 13 tens, we need to share those between 4. So we can say 1, 2, 3, 4. If we want to do by counting, 1, 2, 3, 4. 1, 2, 3, 4. And hopefully many people would have known that 13 shared between 4 will give 3 each. That leaves us with our final 10. That can't be shared in tens between 4, so we exchange that for 10 ones. Bring those. And again, I've done this in 10 frame style. Oops, and we've now got 16 ones. I've got 16, I'm going to share those between 4, so I'm going to put 4 over there, I'm going to put 4 over there, I'm going to put 4 over there, and then I've got 4 over here. And so the answer to 136 shared between 4, the exact answer with apparatus is 34. If I now write that one on a card, I'll just put that one over here, 136. 136 shared between 4. What did we just do? We had 100. I'm going to get a different coloured pen. We shared that between 4. We couldn't do it, so we exchanged it for 10 tens. Those 13 tens we shared between 4 and got 3 tens each. We had 1 10 left over. We exchanged that for ones. We shared our 16 ones between 4, and we ended up with 34. What we're going to do now is I'm going to put another 2 or 3 calculations on the board, on the table should I say. What I'd like you to do is I'd like to look at them. I'd like you to either draw them out, or if you've got apparatus with you, even better, make them. If you haven't got apparatus, draw them out and follow through the whole principle of division by sharing.
And taking a look at the 3-digit example that we've just looked at again, here's the sense of number, VCP, the visual calculation policy. This is from the concrete pictorial policy. That's available from sense of number showing 136 divided by 4. This is what we've just done. The 100, the 3 tens and 6 ones. You can see we had to exchange that 100 because we can't share it between 4 in hundreds. So we exchanged it for tens. There you can see the tens. There are 5, 10, 13 tens. We share them equally. 3, 6, 9, 12. There's this 1 10 that's remaining, which back in the classroom we exchanged into ones. We then had, you can see in the 4th picture, 16 ones, and those 16 ones were shared between 4, and we ended up with each one having 34. So 136 shared between 4 gives us 34. Again, really nice picture, fantastic for working walls. So I'd heavily recommend having a look at the Sense of Number website and having a look at the visual calculation policy.
So what we've got set up now are 2 3-digit calculations, 3-digit divided by 1. Have a look at them. Think about what they actually mean, and then as I say, practice either drawing or making them, or just talking through what you'd actually be doing. Let's have a look at the calculations. We'll then pause the video. So let's take a look at 265 divided by 5. We're going to share those 200s between 5. You look at those hundreds, there's only 2 of them, so I can't share them in hundreds. So this time I need to exchange for 20 tens. Put these over here. I'm going to bring 5, 10, 15, 20. What I've now got, I've got a lot more tens now. I've actually got over here 26 tens altogether. I've got to share those between 5. 1, 2, 3, 4, 5. Worked very well. That left me with 1 10. That 10 cannot be shared between 5, so I need to exchange that for 10 ones. There's 5, 10 ones. I've now got 15 ones, which I need to share between 5. 15 shared between 5 will give me 3 each. 3 there, 3 there, 3 there, 3 there, and 3 there, giving me an answer of 53. As you can see, for the next calculation, we've got 372 divided by 6. We're going to use the sharing model of division. Those 300s will not share into hundreds between 6. What I'm going to do is I'm just going to pause the video while I exchange those 300s for 30 tens. So what I've now done is I've exchanged my hundreds for tens. So I've still got 376. There's my first 100, which is 10 tens. Second 100, another 10 tens. My third 100, another 10 tens. I've now got 37 tens. 370, 37 tens. I'm going to exchange, or sorry, I'm going to share those 37 tens between 6. So 37 shared between 6 will give us 6 each. Let's just prove it. That's my first 6. I'll put those together. I'll do this one egg box style, or a tens frame style. I've got my second 6. I've got my third 6. I've got my fourth 6. I've got my fifth 6. And I've got my sixth 6. So therefore, I've now got, I can see down here, 6 lots of 60. So I have 36 tens shared between 6 is going to be 60 each. That gives me 1 10 left over. I'll exchange that 10 for 10 ones. 5, 10. I've got 12 ones, which I can definitely share between 6 very easily. I'm going to put 2 there, 2 there, 2 there, 2 there, 2 there, and 2 there, meaning 372 shared equally between 6 gives me 62. So 372 divided by 6 is 62. So finally, I've just prepared a very straightforward 4-digit calculation, just where we can use the same principles. We've got the calculation 1,332 divided by 6. I've kind of pre-prepared the resources so I can do the exchanging straight away. Let's have a quick look. Here's 1,000, 300s, 3 tens and 6 ones. Immediately we can see this cannot possibly be shared between 6. In thousands there's only 1,000, so I'm going to exchange that 1,000 for the 10 hundreds that I've prepared earlier on. So we're bringing those down there. Move things around a little bit. Bring these over here. I can now see I've got 13 hundreds. Those 13 hundreds can be shared between 6. There's 200s. There's another 200s. There's another 200s. Oh, let's move that over there a minute. Another 200s. Another 200s. And a final 200s. So again, we can see we've got that. We've got 100 left over. That can't be shared between 6. I'm going to exchange that for 10 tens. So I've now got, so I'm going to bring these back over here. I've now got 13 tens. I'll share those between 6. I'm going to put 2 tens there, 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 and finally 2 tens over here. 1 10 remaining. I can't share that between 6. I'll exchange that for 10 ones. So there's 5 ones. And there's another 5 ones. I've now got 12 ones. They can again also be shared between 6. 2, 4, 6, 8, 10, 12. So even with a big number, it doesn't take that long to actually show the children what it actually means. 1,332 divided by 6 is 222. Just to conclude, I want you to look now at the 3 calculations we've just done. I'm going to imagine these now. I'm going to write the hundreds, the tens and the ones, the hundreds, the tens and the ones, the thousands, the hundreds, the tens and the ones. I'm just going to ask you to look at those calculations and now to imagine explaining them properly as we've just done on the desk using the apparatus. So if we now go through each of those one by one, we'll pause the video, go through them and discuss what do they actually mean.
this isn't the exact example that we looked at in the classroom. I'll just leave you to have a quick look at this one. 1,278 divided by 6 as a slightly higher level 4-digit number example. What do we start off with? Here we start off with 1,000. That can't be shared between 6. We exchange it into hundreds. So we've now got 12 hundreds. Well, that can definitely be shared between 6, 2 hundreds each. Nothing left over this time. So we've just got straightforward 12 hundreds. You can see there, shared between 6 gives 2 hundreds each. You can see how the whole thing's color coordinated here as well. We then move that up into the tens. We've now got 7 tens. Well, we can share those 7 tens between 6 and get 1 10 apiece. That leaves us with a final 10, which is exchanged into ones, and then those 18 ones are shared between 6. I think you can see how easy it is the more you do it. The more you get the apparatus out. I think if this particular method was used with children, and again, I would probably move from here into place value counters, use this with children, get them to get the apparatus out, get them to do the exchange, and suddenly they'll be able to talk you through it really, really easily. So even a complicated calculation like this can be explained relatively easily.
So on the first one we have 100. In hundreds cannot be shared between 4, so I exchange those hundreds at 100 for 10 tens. My 13 tens, as we proved, can be shared between 4. There are 3 tens each. That leaves us with 1 10, which we exchange into ones, and we can see that is now 16 ones. 16 ones shared between 4. On the table we got 4 each. The next example, we actually had 2 hundreds. They couldn't be shared in hundreds between 5, so we had to exchange them into tens so they could be shared. We exchanged the 2 hundreds for 20 tens, and we ended up with 26 tens. We shared the 26 tens quite easily between 5, and we got 5 tens each. There was 1 10 left over, and that was exchanged into ones. The 15 ones we then shared between 5, and we ended up with 3 each. So you can see how this method now makes complete sense because of what we did on the table. We've got to give the children enough opportunity on the table to see it before we start showing them the method. The method should explain what they've just done. Last but not least, the 4-digit calculation. I'd probably normally do this with place value counters rather than the apparatus, just for ease. We had 1,000, we tried to share the 1,000 between 6. That can't be done in thousands because we only had 1 of them. So we exchanged that for 10 hundreds. We now have 13 hundreds. 1,300 is 13 hundreds. 13 hundreds shared between 6. We got 2 hundreds each. There was 100 left, so we exchanged that 100 into tens because that 100 couldn't be shared between 6. We now have 13 tens, or 130. Those 13 tens were shared between 6, and we got 2 each. There was only 1 10 left. We exchanged that into ones, and we shared the 12 ones between 6, and ended up with 222. So I hope you can see from all the examples that we've done, it's so much better if children really understand what the bus stop method actually means, rather than just saying how many 6s in 1, how many 5s in 2, and how many 4s in 1. We've got all the place value, all the understanding, and we can then develop that as we move division forward.
Thank you so much for watching the video. There is, as I said, a bonus video which does give you a kind of story behind bus stop or short division. It looks at the character partitioning that we've seen in previous videos in the Players Value Week, but now it looks at how numbers can be partitioned in different ways using an image or a story that you can use in class. So if you do get the opportunity, it's only a very brief video, a few minutes long. Do take a look at the partitioning division video. Thanks very much. Hope you've really enjoyed this session. I've enjoyed being able to create this extensive, detailed video on division. It's what I've wanted to do since the start of the training, so I hope you find it very, very useful and that you'll be able to use the ideas back in class. I'll see you tomorrow to continue the mental multiplication strategies that we started before half term. Tomorrow we're going to be looking at round and adjust. See you.